This is SpaceTime Series 29, Episode 49, for broadcast on the 24th of April 2026. Coming up on SpaceTime, interstellar comet 3I Atlas is changing. Large craters offering new clues about the origins of the strange asteroid Psyche. And fighting the growing threat of space junk. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has discovered that the interstellar comet 3I Atlas appears to be undergoing a profound change in the composition of the volatile gases it's emitting. The observations were made by the Subaru telescope in Hawaii shortly after the alien comet made its closest approach to the Sun, known as perihelion. They showed changes in the ratio of carbon dioxide to water degassing from the comet's nucleus. This ratio change is much lower than that inferred by earlier observations using space-based telescopes. The findings suggested the chemistry of the coma, that's the atmosphere of gas and dust surrounding the nucleus, is evolving over time. And that's providing new clues about the comet's internal structure. The study's lead author, Yoshihiro Senaka from Kyoto Sanyo University, says the change is consistent with the idea that the composition of the nucleus of 3I Atlas differs from that of its exterior, and as the comet heated up during its pass by the Sun, gases started to escape from different parts of the nucleus. Now, all this follows earlier observations before last year's perihelion using the Atacama Large Millimeter Submillimeter Array Radio Telescope ALMA in Chile. The ALMA scientists studied 3I Atlas as the sunlight was warming the comet's icy surface before perihelion, in the process triggering the release of gases and dust forming the glowing coma around its core. By analysing this coma, the astronomers revealed the chemical fingerprints of the material it's composed of, allowing them to study how objects are made in different planetary systems. The authors focused on the faint millimeter fingerprints of two molecules, methanol, a type of alcohol, and hydrogen cyanide, a nitrogen-bearing organic molecule commonly found in comets. That ALMA data revealed that 3I Atlas is heavily enriched in methanol compared to hydrogen cyanide, far beyond what's typically seen in comets which are born in our own solar system. On two observing dates, the authors measured methanol to hydrogen cyanide ratios of about 70 and 120, placing 3I Atlas among the most methanol-rich comets ever studied. These measurements imply that the icy material from 3I Atlas was either formed by or experienced very different conditions than those which shape most comets in our own solar system. Now, previous work by the James Webb Space Telescope had already shown that 3I Atlas had a coma dominated by carbon dioxide when it was far from the Sun, and these new ALMA results add methanol as another unusual detail in its chemical inventory. ALMA's high resolution for imaging also allowed the authors to see how different molecules move away from the comet, revealing surprising differences between methanol and hydrogen cyanide. Hydrogen cyanide appears to come, for the most part, directly from the comet's core or nucleus, which is typical for comets in our solar system. But methanol, on the other hand, appears to come from both the nucleus and from ice particles in the coma. These tiny ice grains act like mini-comets as the object moves closer to the Sun, where ice turns into gas and also releases methanol. Similar behaviour has been observed in some solar system comets, but this is the first time the physics of such detailed outgassing has been traced to an interstellar object. Comet 3I Atlas is only the third confirmed object seen passing through our solar system from interstellar space. It follows 1I Maumauer and 2I Borisov. Observations of these objects also revealed unusual properties. As astronomers continue to discover and study more interstellar objects, science's understanding of planetary formation in other star systems continues to grow more interesting. This is SpaceTime. Still to come, large craters offering new clues about the origins of the strange asteroid Psyche, and fighting the growing threat posed by space junk. All that and more still to come on SpaceTime. Scientists think large impact craters on the surface of the mysterious metallic asteroid 16 Psyche may provide new clues about its formation. Even 200 years after asteroid 16 Psyche was first discovered, astronomers continue to be puzzled over its creation. Psyche is the 10th most massive object in the main asteroid belt between Mars and Jupiter, and at 225 kilometers in diameter, it's the largest known metallic asteroid. NASA's Psyche mission will arrive at this strange world in 2029, hoping to determine its origins. Psyche may be a leftover building block from early planetary formation, the planet having been shredded by violent collisions, or it may have been a planetary fragment that separated into separate layers before losing its rocky outer mantle. Other hypotheses suggest Psyche is an ancient remnant that either started out metal-rich or became a blend of metal and rock after repeatedly smashing into other asteroids. Each of these scenarios has different implications for the origins of planets in the early solar system. To investigate these possibilities, researchers at the University of Arizona ran simulations to try and predict how a large crater located near Psyche's North Pole could have formed under various competing scenarios. The findings, reported in GSR Planets, outlines predictions designed to help scientists interpret the data which NASA's Psyche mission will collect when it arrives at the distant asteroid. Coupled with spacecraft observations, the predictions may help settle the mystery of Psyche's origins once and for all. The study's lead author, Namya Bajal, says large impact basins or craters excavate deep into an asteroid, giving clues about what its interior is made of. By simulating the formation of one of Psyche's largest craters, the authors were able to make some testable predictions for Psyche's overall composition when the spacecraft finally arrives. Fewer than 10% of asteroids in the main belt are metal-rich, and of those, Psyche is by far the largest. Bajal says one of the main findings involves porosity, the amount of empty space inside the asteroid, which plays a significant role in how these craters form. Porosity is often ignored because it's difficult to include in models, but the simulations show it can strongly affect the impact process and shape of the craters left behind. When an asteroid is porous, it's more, shall we say, crushable, and so the impact energy is efficiently absorbed. That leads to deeper, steeper craters with less ejected material scattered across the surface. By comparing these simulated craters with what spacecraft observe, scientists will be able to investigate whether Psyche's interior is separated into layers of rock and metal or instead mixed into a jumble of materials, rubble pile style. This is all really important because scientists will never be able to get to the cores of Earth, Mars or Venus, but they may be able to get a good idea of what a terrestrial planetary core looks like by studying Psyche. If Psyche does turn out to be an exposed planetary core, where most of the rocky crust was blown away for some reason, it'll offer a window into a violent stage of planetary formation which scientists cannot observe any other way. Bajal and colleagues tested two main interior structures for Psyche. One is a layered structure with a metallic core and a thin rocky mantle, which likely formed if a violent collision stripped away the outer layers. The other is a uniform mixture of metals and silicates, created by a more catastrophic impact that mixed everything together rubble pile style, like some metal-rich meteorites found on Earth. The authors used the best-shaped model of Psyche derived from telescope observations to create their 3D target. They reproduced the formation of a specific concavity in the model, about 60 kilometers wide and 6 kilometers deep, as a simulated impact in which Psyche was hit at speeds typical for asteroid belt collisions, around 6 kilometers per second. They varied the size of virtual impactors and then tested the two models, metal core and mixed rock and metal, to see which could reproduce the crater's known dimensions. Each scenario produced slightly different crater shapes and ejector patterns. The authors found that an impactor about 6 kilometers wide would create a crater of the right dimensions regardless of its interior composition. The Psyche spacecraft carries instruments designed to study the asteroid's surface, gravitational field, magnetic field, and composition. In addition to crater shapes, which depend on internal structure and porosity, the simulations also predicted other observable patterns, including variations in the density caused when the impacts compressed the asteroid's interior, and the distribution of metal-rich debris blasted onto the surface. This is SpaceTime. Still to come, fighting the growing threat of space junk, and later in the science report, a new study has pinpointed the likely origins of the spiced nutmeg. All that and more still to come on SpaceTime. Debris from spacecraft is becoming a growing problem in orbit. Nowadays, considerable time and effort is undertaken to track the millions of pieces of spent rocket stages, disused satellites, and collision or explosion-source spacecraft debris currently orbiting our planet. It's a problem made worse by countries like China deliberately destroying spacecraft in orbit to test their anti-satellite weapons systems, in the process creating massive clouds of shrapnel, much of it too small to track, but still deadly were it to collide with a manned spacecraft. Purdue University engineer Caroline Frew is among a small army of researchers searching for ways to limit the threat of space junk. She's looking at ways of tracking space debris, especially as the number of deep space missions to the moon increases in coming years. Right now, NASA's planning more than 30 moon missions in the next few years alone. Frew says everywhere humans have gone in space, they've left space debris behind. And her research is considering how the latest spacecraft technology could affect the formation of space debris. See, unlike previous lunar spacecraft, rockets for upcoming lunar missions are likely to have nuclear thermal propulsion systems in order to be more fuel efficient. The problem is, if rockets with these systems collide or explode in space, their radioactive contents would disperse and become debris. Frew and colleagues have been modelling the consequences of radioactive debris in cislunar orbit, finding that nuclear-contaminated fragments from a nuclear thermal propulsion system could emit radiation kilometres away from an impact site on the Moon. Their models, reported in the Journal of Astronautical Sciences, indicate that these radiation levels could stay elevated for more than a year, threatening any manned lunar base nearby.
Space debris are the human-made objects which are in space. You might think those are only a few, but there's actually a large number around the Earth, and now even pushing further out all the way to the Moon. Once you launch the objects, even when the satellite is long dead or the rocket upper stage has fulfilled its mission, it stays in orbit. It does not automatically come down. Up to an altitude of about 1,000 kilometers, there's drag, meaning they lose energy, they might come down very, very slowly. However, anything further out, where our GPS satellites are, where our TV satellites are, there's no mechanism bringing them down. They can stay there forever. So we have basically three lines. We have the observations, we have the astrodynamics, and the characterization. One thing we have added to the research is no longer only looking in the near-Earth space, but also looking at the cislunar space, which is further out. With all the new and exciting missions like Artemis, we are having more traffic into the lunar region around the Moon, but also all the space between the Earth and the Moon. While that is cool and exciting, it does create the problem that we have space debris in that region as well. So for one, we have the Purdue Optical Ground Station, where we actually take observations of the objects in near-Earth space and cislunar. That includes the active satellites, but also the space debris. We can do mission support, for example, in that realm. And then we are looking for the astrodynamics. One is, how do we keep the spacecraft safe? What is the probability of collision? How can we compute that efficiently? How can we aid in go, no-go decisions when a collision comes up, when there are fragmentation events like an explosion? Where do the pieces even go? While in the near-Earth space, we have a better idea. In cislunar space, they can actually go to the Moon, they can come all the way back to the Earth, or just keep hanging out. On the characterization, we want to see what can we learn about the objects beyond their center of mass. They're very far away, we are not getting a resolved picture of them, but how can we still know like in which motion they are, what shape they have? That's important when you launch a mission and you lose contact. Are we still oriented, that the solar panels still get energy? Are we in free tumbling motion? That's usually a bad sign. How can we recover from that? When do we have the antenna pointed in the direction that we can try to make contact or reboot? It's also relevant for active removal of space debris. If people are planning a mission to remove space debris, go and grab it, more or less. The better you know what pieces you're dealing with, what's the shape, how much rotation do they have, the better you can execute those missions. We have a number of challenges. One is large constellations. We have a larger number of active spacecraft in space at the moment than ever before. This means they are flying relatively dense to each other. So we want to be aware, avoiding collisions, but also be aware that we're not littering and leaving the space debris behind, and how to manage the different interests that are in that space. The other big challenge is the cislunar missions, the missions that are going to the moon or to the L2 Lagrange points, like the Artemis mission. That's creating traffic in an area of space which is not used to have a lot of missions going there. And then how to balance them, how to make them not run into each other, how to avoid having explosions in that space and having all the pieces flying around to the moon, back to the Earth, and everywhere in between. These are some of the challenges which are on the technical level, but also on the legal level. We are working mostly on the technical level to have solutions ready in order to tackle those problems. Working on space debris is usually considered like the spoil sports people, because everybody wants to do the cool missions and actually go places and provide technologies, services, or explore space. But the problem of debris is real. Everywhere where humans have been going in space, we have been leaving behind space debris. So in order to tackle the problem, one of the frontiers is mitigations to begin with. We are working that you think about in your mission planning already, what's the end of life, where's the debris going, and how to tackle that problem. So, because the fewer debris pieces we are creating, the better the problem in the end.
That's Caroline Frewer from Purdue University. And this is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Scientists have found that older men are more likely to add extra salt to their food despite its known health risks. The findings, reported in the journal Frontiers in Public Health, used survey data from 8,300 Brazilian adults aged over 60 and found 12.7% of men and 9.4% of women added salt to their foods once they were cooked. The authors found that men who are not on diets to manage high blood pressure are the most likely to salt food after preparation. It seems living arrangements and dietary choices can significantly influence people's discretionary use of salt, with 62% of men more likely to add salt if they live alone. On the other hand, for women who regularly ate fruits and vegetables, the likelihood of adding salt was some 81% or 40% lower respectively. The authors say this might be because this group pays more attention to diet quality, reducing salt intake. We have a bit of good news now, with a new study showing that after more than 40 years since the end of commercial whaling, sightings of the world's two largest whale species, the blue and fin whales, have increased in the southeastern Atlantic. The findings, reported in the African Journal of Marine Science, are based on 60 years of confirmed sightings and strandings from Namibia and the South African west coast. They say that although overall numbers remain low, sightings of both species have increased remarkably in recent years, with 95% of observations recorded since 2012. The results suggest that these ocean giants are slowly recovering from the devastating impact of 20th century commercial whaling, a practice which pushed both species to the brink of extinction. However, the authors warn that ship strikes, entanglement in fishing gear, underwater noise, pollution and climate change all remain serious threats to their survival. A new study has found that one of the world's most iconic spices, nutmeg, probably originated on the Banda Islands in eastern Indonesia. The findings, reported in the Journal of Proceedings of the Royal Society, looked at the DNA of 400 nutmeg plants across the Moluccas archipelago, finding that genetic diversity is highest in the North Moluccas. Now, normally, genetic diversity is highest in a species' area of origin. But this new analysis suggests that the plants originated much further south, in the Banda Islands in the South Moluccas. But that's also where the species has recently undergone a dramatic reduction in genetic diversity. The authors found the plants are likely to have moved north naturally between 10 and 15,000 years ago, long before being spread far and wide as part of human trade. There are claims today that some of the world's oldest financial institutions are concerned over the destabilizing effect the discovery of UFOs and alien extraterrestrial visitations to planet Earth would have on the global economy. It's claimed a report to the Bank of England warns of financial collapse if and when the news comes out, assuming there is news, of course. But as the skeptics Tim Mendham points out, firstly, there was no report, it was just a letter sent to the bank, And secondly, there is of course no news that UFOs or alien extraterrestrials have visited planet Earth.
The headline read, Bank of England fearful of the US disclosing extraterrestrial. Now, that's not true on a few aspects of it. Someone who used to work at the Bank of England for 10 years as a financial analyst, not exactly an astrophysicist or anything like that, has sent in a report to the head of the Bank of England, unofficially, because they don't work there anymore, stating that there's going to be an announcement soon, and this has been sort of said quite widely recently, that Donald Trump is going to release the truth about UFOs this year. Sometime soon. They always say this year, but who knows? And that once the truth of UFOs, the existence of them, is revealed, this is what this letter says to the Bank of England, that it is likely to induce ontological shock and provoke psychological responses with material consequences.
Whoa. Before you go any further, what the heck is an ontological shock?
I think it's back to basics, actually, back to your understanding of the nature of things. It's a shock to your very nature, to your soul. I'm not quite sure why, but the suggestion is that because once the alien existence has been revealed, it will show that earthly authorities are not totally in charge. I'm not quite sure how that works.
Based on past performance, that would be a good thing, wouldn't it?
Well, by relatively speaking, yes. But supposedly these aliens have been around for a long time, at least since 1947. Governments might have known about it. So I'm not quite sure how big a shock this is going to be, say that authorities aren't necessarily the font of wisdom. Another thing in the letter sent to the Bank of England says, if the UAP, unidentified anomalous phenomena, proves to be of non-human origin, we may have to acknowledge the existence of a power or intelligence greater than any government and with potentially unknown intentions. It is entirely possible that the government leadership and their central banks have not been properly briefed on the topic. I will not be surprised. So basically saying that when this announcement is made, any day now, that it's going to shock the banks to their bootlaces and realise that aliens have more influence over the world economy than you might think. But the headline, Bank of England being fearful, no. US disclosing, no. Extraterrestrials, no proof. Therefore, the headlines are, and the report given by someone who used to work at the Bank of England for 10 years and hasn't worked there for a while. So it's not a Bank of England report. It's someone wrote them a letter. It's a tad overblown, I think.
That's the Skeptic's Tim Mendham, and this is Space Time. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.